Fine. So Python scripting, we've made huge changes and strides since 14 through 17. It was just too much difficulty for so many people to get things working. And it's want it to be more than just JSL and Python, the aggregation of it. We've got issues of marshaling data between the two environments, the package support, both being able to load external packages to improve the power of jump within uh, your ability to utilize jump, such as being able to bring in external data formats. There's all kinds of file formats out there, and lots of Python packages support pulling in external data formats, Parquet, HDF5, lots of formats that, while we support HDF5, there's lots of others like Parquet that we don't yet. So you can now bring those in, and makes it easier to pull in the data from external sources. There's statistics out there that we don't have that have Python packages. You can utilize those. Um, and things like GPU support. You can pull in PyOpenCL or PyCUDA and make use of graphics computing. Um, we can wrapper Python with JSL. We can call Python from JSL and call JSL from Python. Um, and then, so we've made lots of improvements to the environment. The Python works right out of the box right now with Jump 18. There's no picking of a particular version of Python because it's one that's supplied with Jump and should be ready to go the minute you launch Jump. So let's then, and think of this as what we want to provide is the best of both languages, the best of both environments here within Jump. And let's get rid of the PowerPoint for now. Drag this off the other screen. One of the best places to find the information on what we've done within the current Jump is the scripting index. I want to talk about a couple things, is that we've added a couple new JSL Python commands, Python install packages. You can install those external packages, most of them right from within Jump. They download, and you'll wind up getting the log messages of them. We can show the second example. It's not the one I want. Yeah, never mind. We can do it for both ways. If for some, there are some packages that have difficulties because they need compilation. You will have to have a development environment on your machine. Some of them install just fine. Others, you might have to put the Python 3.11 from python.org on your machine, do a pip install from that Python, and that will then download and build it in a local cache. Then you can use Jump's install packages to put it in the isolated Jump environment. If you want to install packages from the command line, we've got a command line wrapper script, create jpip command that knows all the appropriate environment variables to put in the script to build a wrapper script. And if we were to run that, it gives us a directory, pops up a JSL directory picker of what directory we want to pick to write the jpip script. And it'll write a batch file on Windows or a shell script here on the Mac. So because we've no longer, it runs right out of the box, things like Python init are no longer necessary. And all of the initial parameters that used to be available in Python init are simply ignored. Python init is deprecated because it doesn't really provide anything. Python control, if you, Python connect is, if you want Python connect, if you need the connection object, if you need the object so you can use send the messages to them, you use Python connect is there. Python control deprecated because it no longer has effect. All that did was set some flags for Python get graphics. Python get graphics is gone. All it did, but what I've done is in the scripting index basically shows you how to do the same thing that we did internally, which was simply take matplotlib, save the figure as an image, and then open it back up, tell Jump to open that file back up. This let us eliminate a dependency on matplotlib, and that's all that function did. Most everything we've tried to minimize any breakage. There obviously there's a little bit here, but wanted to make sure anything that got broken, that had to be broken, we did it here in 18 so that we've got a really strong foundation going forward. The one notable one that we'll probably run into is the Python send. Before, when we sent a data table, it saved the file as a CSV file to the disk and then told Pandas to open the CSV file from the disk. That's problematic. If it's anything more than like big class, which is trivial. Big files blow up when you get them in CSV, and load times, read times is enormous. Plus, there's always the possibility of loss of precision when you go from a binary format to a text format and back to binary. So what you get now is a Python jump data table object. And here we've added to the scripting index a Python category. That this describes what our jump object has and the jump utils object. The jump utils has both the create jpip and a Python version of the pip wrapper that you can run from within pip. And so here we can run, it accepts all the same commands that pip would accept, and we can run pip list, and it's going out and gives me, these are all the things that are currently installed in my isolated jump Python environment. And the best way to think of it is, we're running Python 3.11. Think of this as your own jump private virtual environment. It's not quite a Python VENV virtual environment, but it's close, and we're looking at making it that, but that's not here in 18. But it is isolated so that it should not conflict with any existing Python pipeline that you've got, and it's your own private jump environment. What the big thing that we've got here is the data table object. It allows you to create data tables from Python. It allows you to add columns, add rows, modify those columns and rows directly from Python. So before it was, you could pull a Parquet file in, but getting it to a data table was painful. Now you can easily take the Parquet columns and directly add them as a data to the data table. You can take Pandas columns, and I'll show some examples of doing exactly that, creating a data table from a Parquet file or a Pandas data frame. We can create, so again, here in the scripting index is lots of things. We can create a blank one, for example, directly. And ran it from Python. Let's see. There's properties on it. We can set the name, we can get the name, we can get number of rows and columns. You'll notice here we've got some predefined constants of opening. Most of the jump $ special variables are represented here in the jump class object. We've got a jump version prints jumps itself. We've got a version here that will print the version of this jump object, so that as we make changes and add new features, you'll be able to write in your scripts, you'll be able to check the version number to know, has this new feature there or not, or if you have to code around it. Let's see. So there's add rows. You can add rows to a column. You can close it, and you can tell it whether you want to save it or not when closing. Add new columns. You can build one up from scratch. So we built one up from lists in Python. One of the ones that's really nice on the jump one, it's a good sample example here, is run JSL. So from Python, we can run JSL code, just like from the Python submit allows us to run Python code from JSL. So for here, this one runs through, building a data table from scratch. But for like currency, we currently what the data table supports from Python is you can create any type of column. But in Jump 18, you can only manipulate numeric and character columns directly. That was the focus at this one. We're shooting to add to make sure that the full data table functionality is there from Python to fully interoperate. But getting this whole environment up and all of the interactions and all the pieces, we ran out of time, honestly. But from the run JSL gives us in essence, a backdoor that lets you call the JSL to do things that we cannot do yet from Python, such as setting the column formats or setting the display widths of those columns. So for example, and then here, part of this example was also to show if you've set a numeric column, which is the default, or we could have done jump data type numeric to set it. But if you've sent a bad value, it'll come in as missing. So we'll run just this portion of it. And so we have, for Jill, a missing value of what her hourly rate is. And here's the other example. So the other part of this is JSL uses zero-based indexing, but Python users are expecting, JSL uses one-based indexing, but Python users are expecting zero-based indexing, and that is what we've done. But our data table object, this is column, then row. So this is 0, 1, and we can run that, and there we go. It's live. It's set the column. You have direct access to the table. It's not a copy. This is the one and only data table, and it's seen from both JSL and Python. Because here we'll set the widths and the currency on that column. So there we go. That one's a good one. And the other aspect is, so here you see, wanted to show we created the column. We can access the column either by name or by index. So say if we do print we print the 0 element of the name column, we get Janet. So you can operate on the name either by the column name or by index. If you want to do something like the Python slicing, where you want to print, let's say, every other one, it needs to be numeric. So if we were to print every other column name, what did I do? List. All right. Isn't we got a column object. The column should have a name. Oh well. Bad example. Do it impromptu. That should give us every other name in the name column. Can't type today. All right. So there's lots of samples. There's lots of stuff here in the scripting index. We've also a couple other special variables that aren't present in JSL is where exactly is this executable located? That might be necessary if you want to run using the Python multiprocessing, where if you just naively call the multiprocessing to parallel process something, you'll wind up launching multiple copies of jump instead of multiple copies of Python. And what you want is have the path to the actual executable, the Python executable. All right, we'll go through, that's the stuff in the scripting index. Let me pull up, got some other samples. Let's see. Say, for example, this is one of them I showed at the keynote in Manchester. Was you want to pull in a different statistics capability, a hierarchical clustering scan, HDB scan. We can pull that in from, run the clustering. Here's a simple, here we open the jump data table and we create a pandas data frame from, pull from we create a pandas data frame from the data table and a simple assignment of the data. We run the cluster on it and tell it to plot a tree plot, and we'll get the result back as an image. All right, so there we did the hierarchical cluster scan. We've got an image output from matplotlib, and in our log is the results of the clustering. No, this isn't statistics, but the running a Mandelbrot fractal. This sample uses OpenCL, so it's using the power of the GPU to compute in parallel a Mandelbrot fractal that is 2K by 2K. If I run this on the CPU, which is one of the choices, I can run on the CPU or the GPU. It takes 16 seconds to run on the CPU. If we run the script, that's how long it took to create a 2K by 2K Mandelbrot fractal. And we can look at the log. So it took 4/100ths of a second to run on my MacBook, running this on the GPU. This is, like I said, it took 16 seconds when I ran this, running the same code but runs on the CPU. Let's go. One of mine here, where did it disappear? The array handling one is a good one. This is, we can handle data. So this is showing handling data as lists, numpy arrays, jump columns, as well as some of the little details about how some of this interacts. So simple stuff. We create a couple arrays, or an array from the list. That's a Python array class type, or a numpy array. And create a jump data table. So this one's filled. Columns are empty to start with. And we can set them just as simple as that. Set the column. Come on. There we go. Just click by just assigning the column to the numpy array or the Python list. Now, one of the things that discovered, we created this numpy array as a float 32. Jump's data table is only doubles numerically. So that doesn't work. That also, it's a bug. It doesn't give you any warning either, and that certainly will be addressed. But we can assign it as type double, and that filled in the values for us properly. And then here, again, we can show the missing value. We can pass none, and this is junk data. We can also test that value for missing, because we can test it the same way would. So 0 isn't junk, so it's false, is NaN, but 1 is junk, and so it shows true. We can set missing value by setting it either using none or math NaN, and that just changed those two to NaN. And then I'd like to point out, make sure exception handling is your friend. Here we go, we'll exceed the bounds. And we caught the error, then give ourselves a message that index is out of range. Print DT gives us just the summary information of the table, columns and rows. We want to iterate across the columns and return the name. We can do that. We can print similarly. The list itself is a summary information. If you have a 1,000,000 row table, you don't want to see that in your print. But if you really do want to see all of those elements, you can print the list. in multiple ways. Come on. And like I said, we've already shown that we can show every other element easily enough. With my mouse will actually click on the button. Or we could reverse. So let's see, created a reverse column that put them in different order. We created it with new column and filled it in with the reverse order of the list column. And let's see, we can create a new column, fill it with random values. Now here, we can assign the column to a variable, and that's a column variable, but it's just a variable because if we assign L1 to col, we are not assigning it to the table. We are assigning the list to just the variable. So column is still column R. And random. We can indeed, even though we don't support doing it directly from Python, we can create a expression column. We can create the expression column, and but we can use the run JSL to actually put the formula into the table. And that puts the formula in list plus NP array columns. And again, setting formatting, we've seen that before. So the lists, Python lists and Python arrays, if you try and do addition on them, it becomes a concatenation. Multiplication is concatenating it multiple times. Similarly, the same basically happens with the Python array, gives you the concatenation, and multiplication with a constant doubles the array, or multiple times. NumPy does things differently, where you actually do, if they're the same size, you get an element by element addition of the values of the array, or the multiplication element by element of the values in the array. And I think that's about most that one can give us. This one's interesting. I created a blog post on the community about this one, where we can take and create a function in Python, and then we can create a JSL wrapper for that function. And then to the rest, after that, it just looks like JSL code to it, even though what we're actually running behind the scenes is Python code. So if we run this, so that created the script. If we just execute that script, we get the result where it added numeric values. Now we'll go ahead and create the JSL function. And here, this was a string and a list. And as we saw before, the list gets concatenated, and the string got concatenated as well with the plus. So we had 3 different data types. We passed through a Python function, and we then passed those through the JSL function, and it all handled all those properly. One other thing to know, when we send a jump associative array through Python send, it becomes a dictionary. Becomes a dictionary in Python. Got some more stuff, but probably now would be a decent time to ask if there are any questions.
Oh, there is a question in the chat. I'll read it to
Sure.
you. It's from Audra, unless you'd rather come off mute and ask it yourself. I'll read it. One of the Python libraries I'm using with jump requires a .exe dependency. The only way I could get it to work was by copying the exe and its necessary DLL files into the same folder that has jump_python.exe. Is there a better way to store any dependencies so that they can be wrapped into an add-in so that other users do not have to copy files?
With the add-ins, presently the add-in builder does not recognize Python files. However, I did create an add-in, and then a couple others around here have, if you bundle it up manually, rather than, so you could put it in there, though I'm not sure with the exe or the shared library, you can create, you can create a Python package, and whether it's a local Python package or if you build a Python package up using the .toml file, and if you then jpip install that will stuff it into your site packages, your jump site packages directory. I haven't tried anything that has its own executable, and with that executable having its own shared library. So I'm be worth an experiment, but that would be the other choice there. Yeah. Is there any other questions? I can go
I think
back.
a lot of the other questions, Paul, were around what do you recommend for resources? I think we did link them to some of the older Python integration stuff on the
Sure.
community, as well as the developer talk I believe you
Right.
gave,
So
to get a little more of that.
Sure. So one of the other things that I'll go back to the slides, and we can finish off the slide deck. And if there's time, I can go back and show some more examples. So I go back to the slide deck. That was my next page with some resources. Obviously, the Jump 18 scripting index has lots of information of what we've provided in terms of the jump object and the jump utils object. Python.org docs. We're using Python 3.11. There's several good sites out here and the NumPy docs and Pandas docs. Search engine for Google for things with Python are all great. And then for those that want more Python directly, there's several good Python tutorial sites out there. Nick at Stanford, the Python Docs has one, realpython.org. Google has developers. There's some free Python courses, and Coursera, and Kaggle has lots of tutorial classes. Python is just one of many of its the courses. And that's my slide deck. And I can, like I said, there's a few other, and I'm trying to continue to post things to the community to make sure I share what I've got. We've got, like, here, this one is a parquet example. And the way this one works is we pull PyArrow in and the types so we can check. And we build a data table. We create a function where we build a data table based on looking at the parquet table schema. We find out what the schema is to get its field name. We use the schema to tell what data type it is for us to then build an appropriate jump data type column in the data table, and we fill those values in. This one contained a timestamp column. Jump uses a date starting from January 1st, 1904. Python's date is January 1st, 1970. So in Jump 18, you've got to do a conversion factor from one to the other. But that's work we've already started doing in 19 to actually the Python get and Python send in Jump 18.1 knows about Jump's date time and Python's date time classes. So that work is coming to make so you don't have to know this constant. And for here, it'll create a parquet column. In this case, it's lots of rows, and I picked 4 columns, and that's all it took to build the data table from the parquet column after we had from the parquet file after we'd done a little bit of work to create a function that knows how to map the parquet column to a data table column. So we can run this one. Should be embedded log. We can run the script. So here we go. So we've got a parquet. We read a parquet file that has 1,000 columns, 1,000 rows. I don't remember how many columns it was. Yes, 13. We pulled 4 of those 13 columns. And so the output was, and we set the salary, the formatting of the column, both of these columns, one to date time and one to salary. And we showed the shape of the parquet table. This is the schema details from the parquet table and its column names. So it's easy enough to bring in a parquet table. Let's see. This one is one that I included. So also, we've also have in Jump 18 in the scripting, the sample scripts folder, there's a Python subdirectory that has examples in there as well. One of them is a DT to pandas. This is a better DT to pandas, but the one that's in there shows you how to do what we used to do with Jump. If you want to go with the way it always did of saving the file, saving the Jump data table as a CSV file out to disk and then telling pandas to read it in as a data frame, we've given you that sample code. That I don't recommend that. Here's a better DT to pandas, and this is in the zip file that will be attached with the presentation notes to the page. This one creates a gives us a function that creates a pandas data frame in memory from the jump data table. I separated this out into a separate file that you can load the code in that script. That won't do anything other than put that in memory. That loaded that. And now we have the DT to DF function. And then if we can import files in Python if it's sitting in the same directory, or if it's in the site packages directory. We can just import that. We can import that file as a script. I've already loaded it, but and then I didn't use the local log, but if you don't use the embedded log, it goes to jumps log. But here's the output of the data frame. We use that function to build the data frame from the jump data table. So it's easy enough to go back and forth between Python and a data table. But you've got to know, as all things, you've got to know your data. If the pandas data frame has a multi-dimensional column, that you've got to know. It's not easy enough can't do that automatically. All right, so that's about what I've got. Take more questions if there are any.
Does anybody
Yeah,
have more questions?
Yeah, there's one coming in.
Yeah. Did you say that you can't make add-in files from Python files within Jump? Like, would you have to make the add-in file by like wrapping Python inside like a JSL file?
No, you can include the .py file. It's just that the add-in builder doesn't recognize the Python files in Jump 18, so you can't just pick them and put it together easily. The add-in file is a zip archive, and you've got to assemble that zip archive yourself if you want to dump pure Python files in there.
Okay, thanks.
You're muted, Jordan.
Thanks, Scott. I think I have an example of a Python of a jump add-in that has a Python some Python code in it, and it's up on the file exchange. I'll send a link to it. But however, I'm not proud of the way it's written. And now, since you showed that that Python execute trick, I think I might refactor the way I had written that add-in. So, but I'll post it anyway because it does have an example of an included Python file. It's in the additional files in the add-in.
Yeah, that'd be great. Thank you.
And I'd love to hear from others on where you see opportunities for Python jump integration. I know among some of the customers I've been helping that have been looking at it, it's been very much in the some of the, like Paul said, some of the other types of data types they wanted to access and bring into Jump in a very automated way. And it was helpful to use that Jump 18 Python integration before they go and do the exploratory analytics within Jump and maybe a report out, even pushing it back into maybe a Python output as well. Any thoughts from what you've seen within your organizations or within your peer group?
I've got a silly small example.
All right.
I use Jump's script editor as a text editor as well, and I'm really fond of Markdown. Jump doesn't do Markdown, but I can think in Markdown and write things in Markdown. So Python has a Markdown library. So I just wrote a little like 8-line script to use the jump GUI to ask for a file, and then call that Python Markdown library and create the Markdown as an HTML. I mean, it was a really easy foray into the integration for me, and it got me Markdown.
One other thing I wanted to mention that, and part of this push some of the design of where we went with this, is that, you know, some of the troubles before is because you had who knows what version on each environment, you couldn't be assured that your Python script could run on anybody else's machine but your own. Obviously, if you pull in other packages, they'll need those same packages, but you know for certain that everybody is running Python 3.11 that is running Jump 18. So if your script runs in Python 3.11, it should run everywhere else. And because of that ability to run Jump utils from within Jump, your script can try and install those packages that you may need right from Jump, right from the script before you start trying to use it. And you'll get back, you know, if you were to try pip or try that, the output you get back, if it's already present on the system, you just get the requirements already satisfied. And again, you can put try catches around that import statement, whether or not, if you do the import and you get a failure of the import, well, then you could use that to trigger, okay, let's try and install this package. And then then you would have to do import lib reload to try and reload the package after it happened. But you can do that to all of that can be handled within your Python script.
Any other questions for Paul?
Yeah, or examples of where you can see this helping you.
All right. Well, Paul, that was a great presentation. Thank you. I'm looking forward to going through your materials, which are going to be attached in the community space that Robin is going to put on. Really appreciate it, and looking forward to rolling up our sleeves and doing more work with Python and Jump. Before we close, just a final appeal. Please do, if you're interested in helping us by serving on the steering committee or by suggesting a presentation or even doing a presentation yourself, we'd love to hear from you. You can reach out to us here in the chat, or you can email Robin or myself. And I think that concludes our meeting, and we'll be back at the beginning of June to do it again.